Hi there, it's me, Bill Lindsay, Factory Apps for Linear Tech. And this time we're going to do a little bit of an experiment with interference, also known as jamming, with a Zigbee network as well as a SmartMesh IP network. We're going to show how you can jam a network with a single interfering radio and use that to decide just how robust these two networks are. So let's have a look. Here is the equipment I will be using. This is my Zigbee network. Here on the right is a Zigbee pan coordinator, and then a very similar device is configured to be a Zigbee sensor node. I've got a wire connected to it because it's going to be reading a digital input and reporting data once every second. Over here, this is my SmartMesh IP network. This is the SmartMesh manager in a little USB package, so it's easy to connect to my computer. And here's a SmartMesh IP evaluation mote. This one is also going to be reporting data once a second, although it's going to be reporting its own internal temperature once a second. And then here are my jammer units. These are more motes that are configured to run in a radio test mode. They will just transmit continuously on one fixed channel. They're labeled channel 0, channel 4, channel 11, channel 13. All right, now I've got my two networks set up and reporting data. So I'm going to show you my setup and then we'll start experimenting with interferers. So let's take a look. This here is my little one node Zigbee network. This guy down here, this is the Zigbee router that is reading a digital input. It's on a little push button here. It's a digital input to that device. It is reporting data over the air from this little antenna up to this little antenna on the pan coordinator just a couple inches away, and it reports that data once a second. Everything's powered through a Arduino, and the Arduino also is reading the data notifications as they come out of the pan coordinator. A little Arduino application running on my PC. And what happens is every time a data report comes in, another line gets printed out onto this console. All these bytes sort of identify the serial number of the node that's sending the data, but the thing to look at is the second to last byte here. That 10 will change to a 0 whenever I push the button. It's a single bit in hex, and it's bit number 4. So it shows up as hex 10 or hex 0, depending on whether I've pressed the button or have released the button. But you can see that that's updating once a second, and that's what the router is programmed to do. Similarly, I've got my SmartMesh IP sensor node here, and it's reporting data over the air to the SmartMesh IP manager. And it's also reporting data once a second. It happens to be set up to send temperature data, and that temperature data gets displayed on this little graphical user interface. This line indicates the serial number that's sending it, a little counter, how many times a packet has been received, and then here's the data itself. So approximately 21 degrees Celsius. There's a missing decimal point there, but the units are in hundredths of a degree C. So 21.14, 20.94. It's about 21 degrees C. And this is the counter again of the number of temperature reports that are being sent, but you can see it update once every second. And then I've got these 4 jammers. Each one of them is configured to transmit continuously on one of the 15 available channels in the 802.15.4 radio space. These devices use the exact same kind of radio, an 802.15.4 radio. It's the same 2.4 gigahertz band that Wi-Fi uses. And so people are worried about that being a crowded band and susceptible to interference. We're going to experiment with interference. Part of setting up the Zigbee network is you choose which channel you're going to use. And I happen to have chosen channel 11 out of the 15 that are available. So one of my interferers is channel 11. But first we're going to start interfering on one of the channels that Zigbee is not using. When I push this button, it is continuously transmitting a tone on channel 0. Let me go back and observe that the Zigbee network is perfectly fine. I'm not interfering on its channel, and so it keeps updating once a second. I can push the button and see that it still has no problem reading its sensor and sending its data. The SmartMesh IP network is hops on all 15 channels. Every time the sensor node sends a packet, it changes channels. And so presumably 1 out of 15 times it's probably failing because this interferer is causing it to fail. But it's no problem, it just does a retry on a different channel and gets the data through. No problem. So both of them have no problem at all. I can turn on a second interferer, this time on channel 4. Start it transmitting, and again, as expected, Zigbee has no problem. And SmartMesh IP has no problem. But now I'm going to start interfering on the channel that Zigbee is using. The Zigbee nodes are about 2 inches away from each other, and about 2 feet away I've got this jammer, this interferer. And when I push the button, SmartMesh IP, even though I'm interfering on 3 of the 15 channels that it's using, it's still getting its data through, nothing missing. No problems. But you go to the Zigbee console and it's stopped. Nothing is happening. There's no new data coming. I can push the button and it doesn't read it. It can't communicate because I'm interfering with the one and only channel that it's using. If a 2 foot away interferer can interfere with a 2-inch path, then in real life, if these were 100 feet away from each other, my interferer could be a 1/4 mile away and still cause a problem. Just for fun, I'll turn on a 4th interferer on channel 13, and still, even though I'm interfering with 4 of the 15 channels, the SmartMesh IP network has no problem. It still gets its data through once per second. But still, the Zigbee network is locked up and can't do anything. So just to show that it can recover, I'm going to turn off the interferer on channel 11, and it should right away be able to get data through. So sure enough, it's sending. Now the console is back, it's reporting data once a second. I can push the button and it reads 0. And so that shows what we were trying to demonstrate, that a Zigbee network operating on a single channel can be completely destroyed by a single radio interferer. And even if you turn on multiple radio interferers, a SmartMesh IP network can work around it. So for high reliability data applications where you can't afford to have a single interferer cause the loss of your data, a SmartMesh IP network is substantially more robust. So I hope you liked this experiment, and we'll see you next time.